Hey guys, so today we're going to be looking at the scalar feature, and we're basically going to be looking at how you can bring two incomparable values and basically bring them to a format so you can compare them. So here we go.
Okay, so today we're going to be looking at scale features, and we're basically going to be looking at what scale is, and then we're going to be looking at this example. So, and we're referring to W3 School as usual. So, if we start off with if your data has different values, so and even in different measurements unit, then it's a bit hard to compare them. So one of the examples could be if you have something that's being graded out of 1,000 and something that's being graded out of 100, then it becomes hard to compare if you're looking at for example, it becomes hard to compare if you say 1,000 points and 100 points. Then according to the computer, obviously 1,000 will be a lot more, so it won't equate or it won't state that 1,000 and 100 are equivalent on the scale. So the same way, if you have, for example, kilograms compared to meters, or altitude compared to time, so then to fix this, you basically use scaling. So you can scale data into new values that are easier to compare. So then you can maybe bring it all into percentage. So if you have 1,000 and 100, then if you have 770, so both are 70%, even though 700 is much larger in magnitude compared to 70. So yeah, so if I run this over here, and while we wait for it to happen, then so basically the answer to the problem is scaling. So you can scale data into new values that are easier to compare. And then we have the same data that we use in the multiple regression chapter, again picked up from W3 Schools. And then basically so the whole table is on W3 Schools, so you can go there and download it. And we'll look at the results in a second. So if we continue with the examples, it can be difficult to compare the volume of 1 liter with the weight of 790 kilograms. But then if you scale them both into comparable values, then you can easily see how much one value is compared to the other. And there are several different methods of scaling data, obviously. And here we're basically using standardization. And standardization uses the formula. I'll just write down the formula as I read it. So standardization, that basically uses the formula Z is equal to X minus U whole divided by S, like this. So here Z is the new value, or basically what we're trying to get. X is the original value, U is the mean or the average, and S is the standard deviation. And we have studied standard deviation before, so you can just look at that video. And if you take the weight column from the data, so then from the data set, then the first value is 790, and the scaled value will then be minus 2.1. And if you take volume, so basically 790, I mean that you basically put X is equal to 790 as in the original. Then the mean of all the data is 1292.23. And then you basically divide it by S, which is standard deviation, so 238.74, which is equal to minus 2.1. So then that becomes the scaled value for the weight column and for 790. So here you can see minus 2.1 basically. So it's using this formula only that's derived. And if you take the volume column, and the first value is 1 if you look into the data that there is. So basically then you say X is equal to 1, U is equal to 1.61, and then whole divided by the standard deviation 0.38. And that becomes equal to minus 1.59. And now you can compare, basically the result is, now you can compare minus 2.1 and minus 1.5 instead of comparing 790 with 1.0, or 790 and 1. And so basically the whole point is that you don't need to actually do this manually for every value. So instead, Python has this module and it has a method called standard scalar, which returns a scalar object with like methods for transforming datasets. So here we're basically like importing pandas and then using the standard scalar or importing it. Then we're setting the scale over here, then we're reading the CSV file. And basically like, this is a warning because I struggled a bit with this, but when you download like the data.csv, make sure that the name matches and you don't put an extra.csv or anything. And then you move it to the same file in which like on your computer the Python file that you're trying to run it in is. So you need to bring it down to the same place so that it gets easier, or you need to like give it the exact path. So here I basically moved it like to the same area where this test.me file is. So you can basically figure that out. And then there is x is equal to df. So here we have the weight, which is on the x-axis, and the volume, which is on the y-axis. And then here we're basically getting the scaled result, and then we're printing it. And this is a formula that you can use manually just to check if you really want to.